Tens of thousands of consumers are still without electricity in large areas of the southern part of Sweden because of the damage caused to overhead lines by fallen trees.
Flygtrafiken på Sturup och Visby.
Despite the highly developed techniques used for the distribution of electricity, the security of supply is still vulnerable to the effects of weather. Storms and the accumulation of wet snow can cause trees to fall onto or come into contact with the overhead distribution lines. In order to overcome this problem, Smålands Kraft is currently rebuilding and extending its medium voltage network using a new overhead wire system known as BLX. A year ago, we decided that all new medium voltage lines should have insulated conductors. So far, we have installed about 250 kilometers. This way, we hope to eliminate any lengthy disruptions to the supply caused by trees falling onto the line because of high winds and wet snow. The system incorporates PEX insulated aluminium wire conductors. They are grease-filled at the factory to prevent axial transmission of moisture should the insulation become damaged. The insulation is 2 millimeters thick and provides a tough protective coating around the conductor. The construction of a BLX line differs from a conventional line. On the whole, the procedure is a lot easier, though care must be taken to keep the wire clear of the ground to avoid damaging the insulation. The most noticeable difference, however, is that the phase spacing has been reduced to 50 centimeters, giving shorter cross arms and narrower rights of way. The best thing about it is the reduced phase spacing and the smaller, lighter cross arms. Makes lifting a lot easier. You use your arms less. It's more legs and shoulders, which saves your back. On the whole, the installation work is a lot easier since you don't have to lean so far out when lifting the line or installing the connectors and fittings. Before jointing the new conductor, the insulation has to be stripped away. At Smålands Kraft, the ends are fixed together with a grease-filled compression sleeve, which is applied with a hand tool. The grease fills all the cavities in the joint, thereby preventing possible condensation and corrosion. Two different methods are used for re-insulating the joint. You can either cover the joint manually with self-vulcanizing material and then a layer of tape. Or you can use a shrink sleeve, which is fixed in place by applying heat. The conductors are anchored to the insulators by means of plastic-coated helical ties in order to prevent them from slipping laterally. Insulation damage due to flashover from lightning-induced overvoltages is prevented as follows. A special insulation-piercing connector fitted with an arcing horn is attached to each side of the insulator. These horns are connected together by means of a bare aluminium wire spiral, which leads any flashover arc away from the insulator and on to the arcing horn. A high-speed camera lets us observe what happens in that fraction of a second when lightning strikes. The arc starts at the insulator and works its way out along the connecting wire spiral on the arcing horn. The arc connectors are designed to withstand 10 kiloamperes twice. In performing this test, several centimeters of the arcing horn were burnt off, but the connector and the conductor insulation were not damaged. At crossroads, arcing connectors must be installed at all pole positions. In order to increase the protection against lightning and to facilitate the correct connection of temporary earths even further, Smålandskraft has also decided to install connectors at every fourth pole and at all large angles. In this way, the linesman will always be able to see the temporary earth connection from the pole on which he is working. In the summer of 1990, Smålandskraft started up a severe long-duration field trial of the BLX system at a distribution station in Eksjö. 5 trees were leaned against the conductors and were then connected at the base to the station's earthline system. The aim of the test is to determine the effects of a tree lying across a BLX conductor for a long period of time. Hopefully, nothing will happen, but if anything does, we will know exactly how. During the test, the 0-point voltage, current and phase angle are measured. Already from the start, the wires were touching in a number of places. Many, no doubt, thought failure was imminent. In the meanwhile, Smålandskraft continues rebuilding and extending its 10 kilovolt network using the BLX system. The company is engaged in a project aimed at halving system interruption times within 5 years. 75% of the network runs through forest. For every mile built with BLX, resources are released for repairing faults on old lines. That this will reduce interruption times is already apparent, though only a small part of the network has so far been replaced with BLX. Using insulated conductors is more expensive initially, but the reduction in downtime more than compensates for this in the long term. This test is very interesting. So far, the results have been positive in that no failures have been recorded. The distribution security demonstrated is indeed a major advantage. We at the National Energy Administration are very enthusiastic about the system. If all goes well with the existing installations, other utilities will most certainly start to build BLX lines as well. The test is still in progress, and by now the trees have been rubbing against the conductors for 3 months. No faults have been recorded so far, and the conductors have suffered no apparent damage. The test will be continued until the spring, and if nothing has happened by then, we will damage the conductors until a fault is induced. Modern farming is highly dependent on a reliable supply of electricity for the milking, the air conditioning, the water for the animals. Since we got our new BLX line, I feel a lot more secure. At last, I can get a good night's sleep knowing that nothing will happen, even with a snowstorm just around the corner.